the complete account of the total ATPs generated during the catabolism of one glucose molecule. So we are here specifically talking about one glucose molecule when it undergoes complete oxidation, that is complete aerobic respiration. How many ATPs will be produced and where are they getting produced? Here we have taken two divisions. One is SLPs, that is ATPs produced directly at substrate level phosphorylation, and the second one is the ATPs that is produced during the oxidative phosphorylation of NADH and FADH2. So we can call this also as the respiratory balance sheet. So this balance sheet, what it does is it gives an example, it gives an idea of where, how many, which step of aerobic respiration is generating how many ATPs and through which process is it generating the ATPs. Now, under substrate level phosphorylations, the first step we will talk about is glycolysis. Now, in glycolysis, there is 4 ATP that is generated under substrate level phosphorylation. In step 7, that is conversion of bisphosphoglyceric acid to phosphoglyceric acid. So in that step, you will have 2 ATP. And in the 10th step, where phosphoenol pyruvate, when it is converted into pyruvic acid, in that step you get 2 ATP. But because in the previous steps of the glycolysis, 2 ATPs are already been used, specifically in the first and third step, the net gain of ATP in glycolysis is considered to be only 2 ATP, because in the same glycolysis, 2 ATP were previously used. So when you take out the balance, you have only 2 ATP as the net gain. That is for glycolysis. The second step is Krebs cycle. Now in Krebs cycle also, you have the production of direct ATP, that is you will have the production of 2 ATP in the cleavage step. When succinyl CoA is converted into succinic acid during that cleavage step, 2 ATPs are produced. So, during aerobic respiration, you are having something of 2 plus 2. 2 here and 2 here. So, 4 ATP are added if you are considering the net gain, and if you are considering the gross gain, then it is 6 ATP. If you're taking the gross, it is 6, and if you're taking the net gain, it is 4. ATPs are added directly from substrate level phosphorylation. Now, when we go to oxidative phosphorylation, then you have the first one will be the cytosolic NADH, which is coming from glycolysis. Now there are 2 cytosolic NADH and we've already seen that each one is worth 2 ATP. So we get 4 ATP. Next is the mitochondrial NADH, that is coming from the linked reaction. So we'll take the linked reaction mitochondrial NADH. So there are 2 and they are mitochondrial. So each one is worth 3. So 2 into 3, 6 ATP. The next mitochondrial NADH, they are coming from the Krebs cycle. We'll write it here, from the Krebs cycle. So there will be 6, each worth 3. So 6 into 3, that is 18 ATP. And you have the FADH2 molecule that is coming. There are 2 molecules, each worth is 2. We've already seen. Please go back to the electron transport of the FADH2 to understand how these number of ATPs have been generated. Okay. So 2 into 2, 4 ATP. So when I do a combined total, here I am having 6 plus 4 is 10, 28 plus 4, 32 ATP. So 32 ATPs are generated or are given to the aerobic respiration by oxidative phosphorylation of NADH and FADH, whereas 4 or 6 depending on gross or grain are coming from substrate level phosphorylation. So if I add both of these, that is 1 and 2, if I combine them both, the total number of ATPs that are generated are 36 ATPs or 38 ATPs depending on the gross and the net gain and the plant and animal tissues. Now there is one thing that you have to consider here. This is an older calculations, though it is given in the NCERT syllabus. If you pick up any higher education books of biochemistry or plant physiology or animal physiology or cell cytology books at the undergrad or at the postgraduate level, you will see nowadays that a new calculation has come up, which has been given in many of the high-end publications and books, that the total amount of ATP that is generated in for one amount of glucose when it undergoes complete respiration, the current value that they are giving is 32, whereas the older calculations was 36 or 38. But because the NCERT is given 36 and 38, we will be considering that only. But this is for your information that the upgraded or the current amount is 32. How it has come up, for that you can refer any of the higher end biochemistry or plant physiology or animal physiology books, and you will get the answer there. This is the ATP balance sheet.
For more content, like, share and subscribe to www.i-win.in.